Hey everybody, Mr. Piercy here, and we're going to be looking at probably our last lesson here before we wind up taking our test over the relationships of inside of triangles. And what we're going to be looking at today is known as the triangle inequality theorem. Now, uh, in my demonstration video that I made to go along with this lesson, I showed a couple of things, but one of the things I did not show is what we're starting with here on example 1. It's asking you to mark the largest angle, the longest side, the smallest angle, etc., and then say what do you notice. Now what they're getting at here is they're actually building up to what they're calling a theorem, but it's not really named. And personally, I don't really mind that it's not named because to me, what they're demonstrating here is not really a theorem. To me, this is kind of a postulate. I can accept what I'm going to see here is true without really having somebody to explain to me why it's true. Okay, so let's look at the largest angle. So here's the largest angle and here is the largest side. Okay, so well, let's go to the next one. Let's actually look at the smallest one. So the smallest angle looks like it's this guy right here, and the smallest side is that guy right there. And so, and my pen is awfully wide. Let me change that. So now let's look at, let's see, what color will show up okay. I don't know if yellow works. Let's do green. So the next one in the middle is that one right there. So what do you notice? Well, obviously the biggest side is across from the biggest angle, and the smallest side is across from the smallest angle, which kind of makes sense to me. Like I said, it's not rocket science here. It says, okay, if we have an angle that's really small, well, you don't have to open up your arms very wide to, pick this, whatever this thing up is. But if you're going and grabbing something that's really, really big, well, then you got to open up your arms bigger. So the angle is going to be more. The bigger the side, the bigger the angle across from it. Because that's, it's just common sense to me. Maybe there's a physics lesson in there somewhere, I don't know. But the smallest side is across from the smallest angle, and the largest side is across from the largest angle. And that's essentially what they're getting at here, where they're saying this is theorem 5.10 and 5.11. They couldn't even be bothered to name these theorems because they're really not theorems in my opinion. Simply saying that the larger side is across from the largest angle and the smallest side is across from the smallest angle, or vice versa. So if they tell you the sides, well, you can tell where the biggest angle is based on the sides. And if you know the biggest angles, then you know where the biggest sides are. Just that simple, I think. So here's where they're kind of giving you an application for it. We have this dock, and people are going out exploring. They're taking a boat for a couple of trips here. And so from the dock to the cave, it's 2,500 feet. From the dock to where they went to the beach, that was 6,000 feet. So they're creating this triangle here, 2,500 feet, 6,000 feet, and 5,000 feet. And what the question is asking is, what is the angle measure of the path made at the cave? What they're asking for is, what is this angle here if they're giving you some other angles to work with? Well, first of all, because the cave is across from the largest side, it must have the biggest value of an angle. So when we take the difference of 180, 55, and 24, we get the cave, the angle there between the dock and the beach, to be 101 degrees, which, like I said, is not really a big surprise that the biggest number for an angle must be across from the largest side of the triangle that's formed. So here, let's go ahead and take a moment. Go ahead and pause the video when you're ready and answer these two questions. The first one is simply telling you to put the sides in order from the shortest one to the longest one, and then to sketch a diagram with the information that was provided to you in the problem. So go ahead and pause the video. When you're ready, come on back and check to see how you did with my answers. Okay, so hopefully you have your orders of the smallest to the largest sides, and you have your your sketch, I should say, of the triangle based on the information that was given to you. So here, looking at the values, well, we can see that angle P is clearly the smallest angle, so that means segment QR has to be the smallest side. 90 degrees, well, we've talked about this for a lot of reasons, and when we talk about the Pythagorean theorem, the hypotenuse must be the biggest side. Well, this is the reason why, because it has the biggest angle. So RP has to be the longest side with PQ sandwiched in between. So now let's take a look at the sketch that we have for problem 2. So another boat makes a trip who has a pass of 1.5 miles, 2 miles, and 2.5 miles with angles of 90 degrees, 50 degrees, and 37 degrees. So based on where they were located, I'm going to have a sketch somewhere here. There it is. That's going to look kind of something like this. So hopefully you were able to kind of come up with a similar looking triangle based on the dimensions that you were provided. Now this is where we're getting to some good stuff. This is where the demonstration video picks up, where we're talking about the triangle inequality theorem. Now, it's been my experience as I've, worked with high school students who are prepping for SAT exams that this question seems to be something that pops up fairly routinely. Something about the triangle inequality theorem. And there are two really kind of primary things that they're going to be looking at. One is kind of what we're seeing here is how do we determine the range, or how do we determine, let me back that up. How do we know if 3 sides of a figure or 3 segments will actually form a triangle or not? And the other thing that they like to ask a lot of is, well, if you know 2 sides of a triangle, what are the range of numbers that the third side could possibly be? So here what we're going to look at, what it's telling you is that the sum of the lengths of any 2 sides of a triangle have to be greater than the length of the third side, which kind of makes sense. If you're trying to make a triangle, then whatever, like say you have something that's sitting at the bottom of something, a horizontal line, and you have something that's coming up this way and something that's coming up this way. The only way that they'll actually form a triangle is if whatever this side is, let's call this 9 and let's call this, I don't know, 7, whatever those two numbers are, they have to be bigger combined than the third number. Because what you'd see is, so let's say this is still 10, but now let's call this 3 and call this 2. If we tried to drop this side down to where it would meet this side, well, they're not long enough to touch each other, so we don't actually have a triangle. Now, personally, I think what they're giving you is actually a little too much information. I think, and let me clean up my board here. I think as long as you look at the 2 smallest sides, as long as the 2 smallest sides add up to be bigger than the third one, I don't need to look at any other combination of possible numbers. All I want to know is, are the 2 smallest numbers greater than the third one when I add them together? And if so, then we'll be able to form a triangle. And just go and take a look at the demonstration video for a better example than what I just drew on here on the board. So looking at this one, this is where we're really going to get into what I think of generally when I think of the triangle inequality theorem and the kinds of questions that I've seen on college exam materials. So we have this triangle where one side of the triangle is 14 units long and the other side of the triangle is 10 units long. Describe the possible lengths of the third side. Okay? Well, if you've already seen the demonstration, you probably already know where this is going. So what's going to happen is that the difference of the 2 sides, in this case, if I subtract 10 from the 14, that tells me that the third side has to be greater than 4. Because if the third side is 4, it's just going to fall down and make a straight line with the segment that's already 10 units long, making just a line that's 14 units long. And that, if it's a line, it's not a triangle. And so the other way that we could do it is if we could take the sum of the numbers and write them out that way. Well, the third side, if we added the two sides given to us together, we would say that the third side has to be less than 24. Now that's key, because if it's exactly 24, again, it's going to push the other two sides out far enough away that all it does is become a straight line again. Now, personally, this is how, there it is. This is how I like to think of it whenever I'm looking at it, and I really do see this more often when I'm looking in geometry curriculums, where they were kind of looking at it as a compound inequality. What they're doing is they're simply saying, if we take the thing that we're looking for, side x in this case, and we put it in between the two inequalities, we know it has to be greater than the difference but less than the sum. Well, let's put it as a compound inequality, and we usually see stuff written that way. Or maybe it'll just say, and maybe it will be kind of an actual statement that it has to be greater than this but less than that, but still it's a verbal or an English compound inequality versus the way we write it in math. It's the same thing. So here we go. We have a triangle that has one side of 23 meters and another side that's 17 meters. So what are the possible lengths of the third side? That's what we just looked at. So go ahead and try working this one out and give don't just give me the numbers. Actually write down a description that says what the possible lengths of the third side could be. And when you're ready, you have your answer, come on back and compare it with mine. Okay, so hopefully you have a well-constructed sentence. It doesn't have to be real long. We're not in an English class. I'm not looking for something Shakespeare-like. I just want you to be able to communicate with math ideas well using proper English and proper vocabulary. What we were just seeing is that the triangle inequality theorem is demonstrating that the range of possible lengths that the third side of a triangle could be is the difference of the two given sides, has to be greater than that, but it also has to be less than the sum of the other two sides, because if it's exactly, if it's exactly the difference or exactly the sum, we don't have a triangle. We wind up with a straight line. So here I would say just the third side of the triangle must be greater than 6 meters, but less than 24 meters. Like I said, it's, nice, tells you exactly what we're looking for, but it doesn't need to be overly complicated or long. But a statement like that is, a step in the right direction as far as how we're able to communicate mathematical ideas in English. And that's one of the things that ultimately when you get into calculus, that's what they're going to be expecting you to be able to do on an AP exam. So that's about it for the triangle inequality theorem. The two main ideas that you really need to know is that this last one that we were just looking at, the sum or the range of numbers of the third side of a triangle could be, is found by taking the sum and the difference of the two given sides. And if I know three segment lengths, how do I determine if I have a triangle between them? Well, if the smaller two numbers add together to be bigger than the third number, or the third side of a triangle, then that's what will produce an actual triangle. So hopefully we're going to be ready to take our test soon, but if you're not comfortable, we've still got a little bit of time. But make sure if you have any questions or things you want to get cleared up on this lesson, shoot me an email, leave me a comment in the Google Classroom, something, and I'll be happy to help you with any issues that you have. But until next time, guys, thanks for watching. Take care, be well.